Hi and welcome to this video on Oxford Math 2014 question J. The first thing that stood out to me when I looked at this question was this term on the right hand side, this integral of f of t dt. The first things first that you want to do with this type of question is understand what's going on. Now this is just going to be a number, okay? It's just going to be a value. So what I can do is I can just say, well, let the integral of f of t dt just equal a, okay? Just a is going to be a number. So I'm just going to rewrite this top bit. 6 plus f of x equals 2 f of minus x plus 3x squared a. Now, I'm interested, or rather the question is asking for the integral of f of x, and I've got f of minus x here, so I want to replace that. So first thing I'm going to do is I'm going to let x equal minus x, rearrange that in terms of f of minus x, and then substitute it into the original equation at the top. So 6 plus f of minus x equals 2 f of x plus 3x squared a. So this means that f of minus x equals 2 f of x plus 3x squared a minus 6. Substituting this up into here gives me 6 plus f of x equals 2 lots of f of minus x, so 2 lots of this, 4 f of x plus 6x squared a minus 12 plus 3x squared a. So I'm interested in f of x, so I'm going to rearrange this to get f of x. So bringing f of x over here, I will get 3 f of x. I've got 12 here, so bring that over, give me 18. I've got 6x squared a and 3x squared a, so it's 9x squared a, but bring it over, so minus 9x squared a. I'll then divide everything by 3, so I get 6 minus 3x squared a equals f of x. Now, what I want to do is I want to integrate both sides between 1 and minus 1, because that will give me the value that I'm after. So if I integrate this between minus 1 and 1, pretend there's a dx in there, I don't really have room for that, which I'll squidge it in that end. Then, well, what happens? Well, this right hand side, what does it become? Well, the integral of f of x between minus 1 and 1 is exactly the same as the integral of f of t between minus 1 and 1. So it's just going to become a. Now, if you're not convinced of that, if I just draw a general function and integrate it between minus 1 and 1, call it f of x, call this x. Well, if I just wrote x instead of, sorry, if I just wrote t instead of x, then it's still exactly the same thing. It doesn't matter what that variable is. If it's f of s, f of p, f of r, it doesn't really matter. If it was g of x, then yeah, that would have changed the question entirely. If you're still not convinced of that, if you've seen integration by substitution before, consider the integral of f of x between minus 1 and 1. Let x equal t. That means dx equals dt. What happens to the integral? Well, the limits stay the same, and this will become f of t dt. So they're both exactly the same thing. Integrating the left-hand side, well, we're going to get 6x minus, well, remember, a is just a number, so, you know, it's just part of the coefficient of x squared, so it's just going to become x cubed a between 1 and minus 1 here. Substituting that in, 6 minus a minus 6 plus a equals a. Well, that's 12 minus a, so minus 2a equals a. 12 equals 3a, which means that a equals 4.